So once again, I welcome everyone. So today what we will be doing is we will be covering the second, you can say second part of the architecture of 8085 microprocessor. Okay. So I hope my screen is visible to everyone. Just confirm me, guys. Yeah. Okay. Fine. So in the last class, I hope we studied the topic like fetch, decode, execute. Okay, these three terms we understood. We also with the regarding a instruction. Okay, we came to know that there is a memory. Inside memory, for every specific address we can have instructions, and whenever any process want to execute anything, it will first of all put the starting address to the program counter, and then what program counter will be doing, it will take the help of system bus. Okay, and in system bus, if I say, it will take the help of address bus of the system bus, and it will find out from which address, the address which came here, it will first of all search that address in the memory, and after searching that address, what it will do, it will take a control unit will generate a signal that is called memory read signal, and using this memory read signal, address bus will be given the task to bring this data I1 from through system bus inside the microprocessor, inside the internal bus, and will come to the instruction register. Yes or no? And from there it will come to the decoder, and from there control unit will get the information of decoding, and then it will tell to ALU or some other section in order to process the task. Yes or no? So this we studied in last class, and along with this we also studied that we also studied in detail about address bus, data bus, and control bus. Okay, so today what we'll be doing is we'll move forward, and we'll focus on two major parts of the microprocessor, and the two major parts are, first one is registers. Today we'll understand all of the registers, and secondly we will understand this complete ALU section. Okay, now and along with this we will also try to understand all the arrows, whichever arrow you are seeing here, all the arrows we will try to understand that why this arrow is bidirectional, somewhere it is unidirectional, somewhere it is pointing from here to here, why like that, why not here like this. So these three questions will be clarified today. So it's really a very important class. So those who are are not with pen and paper, so I request please be ready with your pen and paper, because many points will come and you have to write down. Okay, so we'll now start with regarding the registers. So as you know, inside a microcontroller, registers plays a very important role. So let's first of all understand what is register. Okay, so if I say in short, the register is the internal memory of 8085 microprocessor. So I request everyone please write down what is register. It is internal memory of 8085 microprocessor. Okay, so if I draw the diagram, so if I write here registers, and if I draw the diagram, the register will be looking somewhat like this. Okay, so it is a internal memory, and generally almost all the registers what you will find, they have 8 blocks. Okay, and in every block you can write either 0 or 1. Okay, so in this way you can fill the data, and you can store it internally for some job as per the requirement. Okay, and these all blocks which you are seeing here, okay, these all blocks which you are seeing here, okay, every block, these all blocks are made up of a hardware, and that hardware is the name of the hardware is flip-flop. Okay, so what is the hardware? So hardware is flip-flop. So what is flip-flop? You can say flip-flop is a memory unit. Flip-flop is a memory unit where you can store one bit of information, either 0 or 1. Okay, so in this register, 8-bit register, we have 8 flip-flops. Okay, how many flip-flops we have? 8 flip-flops. So if I repeat the definition for register once more, a register is a internal memory of 8085 microprocessor, which is made up of flip-flops. Okay, and in every block I can store one data, either 0 or 1. Okay, so this you have to write if the definition is asked. Okay, now if you look carefully, and if I see carefully that how many registers are there and the nature of registers, based on that I can say all the registers are divided into two parts. One is 8-bit register, okay, and one is 16-bit register. Okay, so there are two categories of registers. One is 8-bit register and one is 16-bit registers. Okay, so let's first of all find out all the registers which are 8-bit in nature, and also let's find out which are 16-bit registers. Okay, so I'll write down for you all guys. So first of all, let's see all the 16-bit registers. The 16-bit registers are SP, PC, and increment decrement. So these three registers which you are seeing here, they are 16-bit registers. Okay, so please all of you write down. In 8085 microprocessor, we have three 16-bit registers. One is SP, PC, and increment decrement. So SP stands for stack pointer register. You can write down stack. You might have studied in second semester stack, queue, and all. I hope you might have studied stack and queues. So here this register is called stack pointer. Okay, PC means program counter. This also we studied in the last class. And the third one is increment decrement registers. Okay, they are 16-bit registers. Now a question can come in your mind, sir, why these are 16-bit registers? The answer is very simple, because these registers are keeping the addresses. Okay, so as you know, the addresses are 16-bit. So in order to store the address, we also need 16 bits. That's why these registers are 16-bit size. Okay, so please all of you write down the question. Why these registers, why stack pointer, program counter, and increment decrement register are 16-bit registers? The reason is that they are used to store addresses. Okay, what are they used for? They are used to store addresses. Okay, and you might be knowing that all the addresses are 16-bit type. That's why their size is 16-bit register. Okay, their size is 16-bit. Okay, now let's come to the second part, that is 8-bit register. Okay, so there are actually there are many 8-bit registers. Okay, we'll see all of them. So one is W register, Z register. I'm writing from this part. Okay, W register, Z register, B register, C register, D, E, H, and L. So these all are 8-bit registers. Okay, and along with them there are some more 8-bit registers. They are instruction register. This is also 8-bit. I'm writing here in short IR, instruction register. This flag register is also 8-bit register. So I'm writing, denoting it with flag F. Okay, and this temporary register is also 8-bit register. So and that also I'm writing here temporary TR. And this also is the 8-bit register. So this is accumulator. This is generally represented by letter A. So that also I'm writing here. So all of you please write down the list. So these all registers which you are seeing here, they all are 8-bit registers. Okay, so now I request every student, please write down the list of 8-bit register and the list of 16-bit register. Okay, now later after some time we'll understand why they are 8-bit registers. Okay, so let's just try to understand why they are 8-bit registers. Okay, before understanding why they are 8-bit registers, let's understand what their job is. Okay, see, because once you understand the job, see, the address of these registers were to store address. So their job was to store address, and that's why they require 16-bit. So if you understand the job, you will understand what you will understand, that why they are 8-bit register. Okay, so let's understand job. So okay, let's now let's look one by one to all the register. So this W and Z register, they are used by microprocessor internally in order to store data. Okay, intermediate data. What do you mean by intermediate data? I'll tell you once more. I'll explain WZ once more. Just look here. Suppose I have to add 2, 10, and 14. Suppose there are three numbers. These three numbers I have to add. So what I have to do? I will first of all add two numbers, and after adding I'll get some result, and then I'll go for addition of these two numbers, and then I will get the result, that is 26. Yes or no? So this 12 which you are seeing here, this is your intermediate data. Okay, so for storing this intermediate data, microprocessor 8085 is taking the help of W and Z register. Okay, so in order to store the intermediate data, it takes the help of two registers, that is W and Z. Okay, and you might be knowing or that in 8085 the whatever data you have, they all the data, the nature of data is 8-bit in nature. Okay, the data of address, I mean 8085 microprocessor is 8-bit nature. Okay, so whenever you are going to store data, wherever you are going to store data, that will require how many space? 8-bit space. Okay, so that is one reason, as they are storing data, that's why they are 8-bit register. Okay, so what you will observe that these all registers which you are seeing here, they are somehow trying to store data only. Okay, and that is the main reason why they are referred as 8-bit registers. So in short, I can say 16-bit registers are those registers which store address. 8-bit registers are those registers which store what? Data. Okay, now data can be of two types. I told in the last class also. Data can be instruction also, and data can be some raw data. Okay, some raw data like 2, 10, 14. These are raw information. Okay, some raw information is also called as data. Okay, so this instruction is also of 8-bit, and this raw data is also of 8-bit type. Okay, so in W and Z we are going to store intermediate data, this B, C, D, E, H, L. So these registers are given to programmers. Okay, means these are actually internal registers. Okay, so these are given to programmers, and what programmers can do, they can store whatever they want in these registers. Okay, and whatever they are storing, that will be I mean what that can be some kind of data. Okay, so this is actually given to the programmers. Okay, now instruction register, this is storing what? Instruction, I told you in the last class, and here I have also shown you that instructions are 8-bit type. Okay, so that's why it is 8-bit register. Now here what I mean, when we will understand this part, then I'll explain you why these are 8-bit type. Okay, so I hope now everyone has understood this part. I mean, why they are 8-bit, why these are 8-bit, and why these are 8-bit. Okay, so which one? BC. Oh, okay, this part now. So see guys, listen to me carefully. See, so okay, I'll explain this with a small diagram, that will be better. Okay, all of you look here. So I hope everyone has written C program. I hope yes. Everyone has, yeah. So if I am writing a small C program here, just see that take a number, take two numbers and sum it. So what you will do, you will write like this: int a equal to 10. Okay, I'll take some other color, that will be better. Okay, so int a equal to 10, then you will write int b equal to 20, and then what you will do, you will take one more register, that is int. Oh, I hope it is not becoming clumsy here. Okay, this 16-bit part is clear to everyone. This 16-bit part is clear to everyone. Okay, so I'll erase this part so that I can explain here. So that is really a very important question, like regarding this. Okay, we'll come in detail later on. Okay, but for time being, I'm explaining you. So suppose I have int x is equal to 10, int y equal to 20, and then I'm taking int let it be c. Okay, I'm taking variable c, I'm putting semicolon also because C language. So you can write c is equal to x plus y, and then in C you are getting what? You are getting what? The result, yes or no? So whatever you are doing here, what you are trying to do is, you are trying to take some variables, and in those variables you are storing the data. Am I correct? Am I correct? Yes, yes. And if I ask you one more question, that who is doing this, then you will say that this is done by programmer. Yes or no? Or you can say this is done by a program. Am I correct? Okay. So that thing only I am telling here, that when a program or a programmer is doing this kind of job, so what they will require? They will require some kind of variables where they can store some kind of data. Yes or no? Yes or no? Yes. Yeah, for that reason, these registers are there. Okay, so you can say these registers are some kind of hardware variables. See, x, y, c and all, these are software variables. Please listen very carefully. This x, y, c and all are software variables, whereas b, c, d, e, h, l, these are hardware variables. So hardware variable means they are actually present somewhere. Okay, they are actually present somewhere, whereas this x, y, c and all, they are software variables and they are only present in memory, and when memory is switched off they are also destroyed. Okay, whereas hardware variables are never destroyed because it is a hardware. A hardware cannot be destroyed. Okay, if it is destroyed it will not work anytime. Okay, so this B, C, D, E, H, L are some hardware kind of variables which are allotted to the programmer in order to store some values, whatever they want. Okay, so now I hope it's clear that what is B, C, D, E, H, L and all, and why it is given to the programmer. Yes or no? Okay, so now I hope you have understood that what is the, I mean the description which I have done, that is clear to everyone. Okay, now so you have understood that there are two on the type. See, it's very important. So I have divided the registers into two types based on size. Yes or no? Okay, so based on size, if a question comes based on size, how many types of registers are there? So you can say 8-bit registers and 16-bit registers. Okay, now based on functionality also, the registers are divided into two parts. So please now listen very carefully. The registers based on their functionality, I'm writing here, based on their function. Okay, based on their function, they are divided into two types. Okay, so first type is called general purpose register. Okay, so first type is called general purpose register and second type is called special purpose register. So listen very carefully guys. Now again I am going to create two more, but I will erase this complete part. I hope everyone has written all the registered names and all. Okay, now what I will do is I'll explain you the type of register based on their functionality. Okay, now based on functionality, the registers are divided into two types. Okay, so now let's understand what is the meaning of general purpose register. Okay, so general plus, first of all you listen very carefully and then you write down. Okay, so general purpose registers are those registers which are just meant to store the data, and the data can be of any type. Okay, means you can store the data, you can take out data from here also. So general purpose registers are those registers which are just meant to store any kind of data, and you can even take the data whenever you want. Okay, so those kind of registers are referred as general purpose registers. Means by looking I cannot find out that what that register is used for. I can only tell that that is used for storing something. Okay, so that's why it is called general purpose register. Am I clear to everyone what is the meaning of general purpose register? Okay, so please, it's very important. So general purpose register, I'll repeat once more, general purpose registers are those registers which are meant to store something. Okay, that means it's in a very general way. You cannot distinguish that what it can store in future. Okay, you cannot tell that it can store only number, it can store character, it can store anything. Okay, it can be anything. So that kind of registers are called general purpose registers. Okay, and actually if you look carefully, these kind of registers are especially programmer register. Okay, means because you know that suppose you are writing a program, write a program to find the number is even or odd. So what you will do, you will store numbers. So suppose I am giving you a question, input a name and print how many characters are there. So what you are going to input now, you are going to input a string, yes or no? So if you look carefully, all those registers which are associated with the programmer, they are actually general purpose registers. Okay, because there a programmer can store any kind of data. Okay, so I hope now it's clear to everyone. So what is the meaning of general purpose register? They are those registers I hope I am audible guys. I hope I am audible. Okay, I hope I am audible now. Okay, so yeah, so I was explaining that this is general purpose register means those registers where you can store any kind of data. That's I'm writing here. Okay, now what is special purpose register? From the name only you can understand what is the meaning of a special purpose register. Special purpose registers are those registers which are meant to store some special information. Please listen very carefully. So special purpose registers are those registers which are meant to store some special information. For example, this program counter is meant to store what? Address. That is a special task. It cannot store data at any point of time. So any register which you will find which is used for storing some special information, they will be categorized as a special purpose register. Now I hope it's clear to everyone what do you mean by general purpose register and what do you mean by special purpose register. Kindly confirm, guys. Okay, so I hope, yeah, so now what I will do is, now again I will make a table and I will segregate all those registers which you have seen into two parts, that is special purpose register and general purpose register. Okay, so I'm writing here general purpose register and I'm writing here special purpose register. Okay, now I will not look at the size and all. Okay, so size can be 8-bit, 16-bit, doesn't matter. Now I am only looking that whether it is a general one or it is a special one. So if you remember, I told you all the programmer registers are general purpose registers, means they can be used for storing anything. So they are B, C, D, E, H, L, and one more register, that is A register, which you can see here. So these are actually programmers registers and it can be used to store any data. Okay, so a few of you may be having some confusion, sir, why I have not written here WZ. Okay, so please guys listen very carefully. I'll try to make you understand each and everything. So whichever register you have seen here, they are actually programmers register. Okay, programmers registers. And programmer registers are only those registers where a programmer can use any registers to store anything. Okay, that's why they are called general purpose register. Now why I am not written WZ, actually W and Z falls in the category of special purpose register. Why? Because they are used to store data. Okay, they are used to store data but only with the help of microprocessor 8085. Okay, you can say they are controlled by microprocessor 8085 and only 8085 can write the data here. Okay, no one else can write. So it has been given a fixed job. What is that fixed job? That it can only store whatever 8085 microprocessor will tell to store, nothing else. So I hope now it's clear to everyone why I am putting in the special part. Okay, now if I put here PC and increment decrement, then you can confirm me that why I am putting here as a special part, because they are meant only to store address, nothing else. Okay, even the stack pointer which SP which you are seeing here, that is also a special purpose register. The reason is because it is also meant to store the address of the stack, nothing else. Okay, it can only store the address. Now you will also confirm me that instruction register is also a special purpose register. Why? Because it is only meant to store what? The instructions, nothing else. It can only store instructions. Nothing, you cannot store anything else. It will only store what? Instructions. Similarly, the flag register, temporary register, okay, these two also fall in the category of special purpose register because they are also meant for a special job that I will explain you after some time. For time being, you keep in mind that they are also assigned some special job. So based on this, now please all of you write down these two, make a column and write down that B, C, D, E, H, L and A are general purpose register, whereas other all are special purpose register. Okay, and I assume that everyone is now aware of why this is special purpose, why this is special purpose, and why this is special purpose especially. So wherever I made tick mark, you will be sure. This one you may have doubt, so I'm putting in as a cross mark so that I will explain this part later on, that why they are special purpose register. So I hope this much is clear to everyone. Just confirm me, guys. I hope yes. See, A means, see, A is actually accumulator is the nature of A register. Okay, A means accumulator. That is, it's not correct actually, because accumulator is a nature. Okay, and it is called accumulator here. I'll explain you later and why it is called accumulator. Okay, in other register like if I say 8051 or any other register, you will see that there is a register named as R0, and that is called accumulator. Okay, so what I can say is accumulator is nature, and actually it is called a register. Okay. Okay, so I hope now it's clear to everyone. Yeah, I hope you have written also, so I'm erasing now. Okay, now let's look one more important thing inside this part, and that is, see this register which you are looking here. So this register, whenever it has to perform job, the control unit will only tell, the control unit only can help for this kind of thing. Okay, so what I mean, I suppose 8085 microprocessor wants to store some information inside BC register and all. So this control unit can only tell the any specific register to do that task. Okay, so how those things is done, we'll start with an example. Okay, and in the meantime I'll try to explain that, and as well as I'll try to explain the ALU section as well. Okay, so now let's try to understand this. So suppose I want to add two numbers. So in 8085 microprocessor, whenever you want to go for any kind of instruction execution, you have to write a instruction in the assembly language. Okay, so there is a language called assembly language. So we will be studying in the fourth module regarding assembly language programming. Okay, so let's now look at a small example. So suppose I want to go for this job, that is add B. So this is the instruction which 8085, when it is getting, it will perform the job of addition. Now few of you or maximum of you might be having a confusion in the mind that if I have to add then I need two numbers, but here only one register is shown, that is B. Where is the second number? Okay, so please try to understand what the meaning of this one is. This whenever 8085 will get this kind of instruction, it will assume this instruction as like this: A is equal to A plus B. Okay, so if I say add B, it means this. So if I say this subtract C, what it will assume? Can anyone tell me? Subtract C, what it will assume? Very correct, and I'm really proud of you all. A equal to A minus C, that's correct. Okay, so it means this part, it is pre-assumed that whatever you will tell, I mean only this part will be added. Okay, you know, this is a very basic processor, so some part has to be defined earlier only. It cannot do like a general work as the latest processors are doing. Okay, so it was in the starting, it was made in this format, and that is the reason this general purpose register A is having a special place. It is not located here, it is located just with one reason only, that is it is actually going to store the starting, I mean one data will be stored first of all, and then whenever instruction is passed, it will take the data from second register, and then the task will perform. Okay, so in this way, in future when I'll show you all the instructions, I'll also explain you that how the task is going on. Okay, so for these kind of instructions, in this way the job is done. So I'll now move only with one instruction, that is add B. Okay, so I'm just in the top, I'm writing here add B, which means A equal to A plus B. Okay, now in order to perform this task, one thing is very clear, that in A and B you have to store some data. So I'm assuming that in A suppose 20 is stored, and in B suppose 5 is stored. Okay, so I'm just assuming. How this is done, that we'll see later on. Okay, which command help us to store data in the register, that we'll see later on. Okay, because we cannot take all the all the commands now only, and I will explain everything in detail. Okay, later on we'll see. Just for time being, you believe me that in register A and B some data is stored, and the data I have just assumed as 20 and 5. So I can say here 20 is stored, and I can say in this B register 5 is stored. Okay, so now let's move forward. Now as you can see, if this instruction has to be executed, this instruction has to be brought to instruction register. Yes or no? So, just imagine what I taught you in the last class, that what happens, how instructions are brought. So just using that way, the instruction add B is brought to the instruction register. Now what will happen? The instruction decoder will understand that, and after understanding, it will come to know that it has to perform the task of A equal to A plus B. Now once the control unit comes to know that it has to perform the task of A equal to A plus B, it will assume that if it has to perform this task A equal to A plus B, it has to take the help of ALU. Yes or no? Because ALU is the place where arithmetic operations are performed. It means it will not take the help of interrupt controller, or it will not take the help of serial input output controller. It will actually take the help of ALU. Okay, so what it will do, it will pass some instructions so that the ALU can perform the task. So for what it will do, it will first of all what it will do is, look carefully guys, so what it will do is, it will use this register select. You can see some word is written here. Please look carefully here. What is written here? Register select. So with the help of register select, what it will do, it will choose the register B. So let's first of all understand what is the meaning of register select. So register select is a special circuitry which is used by control unit to select any one register from this space. Okay, from this space, any one register. So you can see there are many registers here. Yes or no? So this control unit takes the help of this register select circuit, and with the help of this, it is capable of choosing one register at a time. Okay, so if it wants to choose register B, only B will be selected. If it wants to choose register C, it will only C will be selected. Others will not be selected. So whichever is selected, that register will pass the information from here to the internal bus. Please keep this in mind. Okay, so with the help of register select, control unit will be selecting one specific register. In our case, that is B register. So it will select the B register, and it will tell that you pass your data to the internal bus, and from internal bus that data will be sent to the temporary register. Why it is sent to the temporary register? Because you know that control unit has told that you have to perform the job of addition. So in order to perform the job of addition, it requires two numbers. Okay, so the first number which is present here will come from here and will go inside the ALU. The second number will be stored in temporary register. Okay, and then it will come to the ALU. Now why I am requiring temporary register here? Because whatever process I have to execute, that process will be having some information, and that information should be stored somewhere for temporary time, so that ALU can use them, it can process them. Okay, so this temporary register is only used for a small thing, that is, it is used to store data for a very limited amount of time, and it is only used to accept the information. No one can take that information, because that information is for very temporary time, very less time. Because as soon as the ALU will get that information, this data will be of no value. It can be anything. Okay, so you cannot believe whatever is present here, and that is the reason, if you look at the arrow here, that arrow is only pointing inside. Okay, so if anyone wants to perform any kind of ALU operation, they have to drop that data to the temporary register, and that will be available in the temporary register for a very short amount of time. Okay, and once the ALU has performed the job, what will happen? We'll get the result. The result is what? 25. And if you look at this instruction, the instruction says that after the result has been after the execution is over, the result has to be stored where? Just can anyone tell me where the result will be stored back? Where the result will be stored back? Kindly someone respond. Where the result will be stored back? Which register? Accumulator. Very correct. You look here. So this 25 which you are looking here, this will pass again to the internal data bus, and will come to the accumulator. Okay, now if you look carefully, or I can just stop here for a little bit time, and just I want you all to just speak out a little bit, that have you really understood what I was trying to make you understand here, that how this small task of add B is getting processed by ALU. Is this clear to everyone? I hope yes. So everyone might have understood. Okay. So if you look here carefully, now what will happen? The result will be passed to accumulator. Now if I just erase this section and if I just show you some important thing again, that is see why this arrow is of two type, because it is a general purpose register, and in general purpose register data can come inside also and anyone can take the data also. That's why it is two-way. And this is why one way, because it is a temporary register, only data can come inside and will be stored for a temporary time. That's why it is one way. If anyone wants to take data from here, it is not guaranteed that you will get correct data. So you may get a bogus data also. Next, why this arrow is like this? Because from here only the ALU will be getting the information for all the information which it has to process. Okay, and instruction of addition will be given by control unit. Okay, so from here it will get data, and from here it will get the instruction of what to do for that data. Okay, now from here the Y arrow is like this, so that it can transfer the result back to the internal bus, and from here that result can be stored anywhere. It can be stored in accumulator, it can be brought to the these registers, or it can be even passed outside. Okay, it can be even passed through data bus outside and can be stored in some output device or memory or anywhere. Okay, that's why this arrow is shown only this way. Okay, so I hope now I can assume that you have understood many arrows whichever is shown here. Okay, I hope am I correct that you have understood, especially if I make a tick mark on which arrows you are clear. Just confirm me guys, just a second. So if I ask you that you are now clear with this arrow, this, whichever I am making a tick mark, just confirm me guys that these arrows you have understood. Just confirm me. Yes. Okay. So okay, one more. This arrow you have not understood. This I will explain you in the next class. Okay, because as the time is ending up, we'll understand that in next class. Okay. Just okay. One more thing. Have you understood these arrows? Just confirm me. These arrows, I hope you have understood. Okay, so I'm sure that this arrow also you might have understood, because actually the arrows which I am showing you here, they are actually of address bus and of data bus. Yeah, and why it is two-way here? Because when it is acting as a address bus, see this part, if you are having confusion, I will make it clear here. See, the address which is coming from here is divided into two parts. There are two reasons. One is, if you look at the system bus, you know that you require address bus and you require data bus. Okay, but the point is whenever address bus is active, that time data bus is deactive, and when data bus is active, and that time address bus is deactive. Okay, so instead of making 16 wires for address bus and 8 wires, that is total of 24 wires, instead of making 24 wires, what has been done, the 8 wires of address bus and 8 wires of data bus, they are clubbed together, because you know that one time they will be only one of them will be active. Okay, that is the reason you look here that A0 to A7 and D0 to D7 is D0 to D7 is referred as AD0 to AD7. I hope you are getting my point. Okay, so they are clubbed together. Why? Because of this reason, because any one will be active at a time. So if it is acting as a address bus, that time D part will be inactive, and when they are acting as data bus, that time this complete will be inactive and A part will be inactive, and only D0 to D7 part will be active. So I hope now the arrows are clear to everyone. I hope that's a very important question. I'll explain. See, the address buffer is like a station. Okay, it is a kind of station. Means if suppose from memory what if suppose you are bringing some data from here, okay, so that data will first of all accumulate here, okay, all the data whatever you have bringing, all the data will be accumulated here, it will be verified here that everything has arrived and or not. So once everything is arrived, then only it will move towards the internal part. Okay, so it is, you can say this is a kind of place where it the checking kind of is done, whether everything is arrived and everything is okay, those kind of things are done here. Okay, is it clear? Okay, so now I assume that everyone has understood this part. Okay, let's have a small idea regarding flag also, which I will explain in very great detail. Maybe I will take 30 minutes to explain this part, and it will also contain a lot of questions in the exam. Okay, so I request that you please try to understand this part. Okay, so if you go for any calculation, like suppose I am doing 7 minus 20, what will be the result? The result will be minus 13, yes or no? Now, yeah, so if you look at this result, the result is having two things. One is a data part and other part is nature of the data. Means whether the result is positive or whether the result is negative. Okay, look carefully guys. So means what I'm trying to say, the data part which you are seeing here, that data part will pass from here and will be stored in the accumulator. Okay, but what about the nature part? Who will take care, who will care about the nature part? The nature part is cared by flags. Means what type of data we have received, what type of data has come in the result section, the nature of that data is actually controlled by flags. Okay, so whenever any execution will occur, okay, so listen very carefully, whenever any execution will occur, the nature of the result will be stored in flags. Okay, and that nature you can, if you want that nature, you can even check. I mean, see, the arrow is outside. The reason is what? That nature you can take and you can use for any kind of processing. Why? Because suppose if I have to find that, then I have two numbers, let it be 7 and 8. I want to find which number is bigger. So what you will do? If I have to find which number is bigger, this will be first number, this is second number. How you will find that which number is bigger? So you can do this. You can go for this. You go for subtraction part. Okay, if after subtraction, if the result is negative, I will say second number is bigger. If the result is positive, like suppose this is 17, so what output I will get? I will get plus 9, yes or no? So if the result is positive, the first number will be bigger, yes or no? So the nature of the result is actually solving the problem, not the output. Output can be anything, but just because of this nature only I came to know that which number is bigger. Okay, so this result, that nature will be stored where? Inside the flag. Okay, and that data which is present here can be used by a programmer in order to find out some solution. Okay, and that is the reason why the arrow is pointing outside. Okay, and why it is not pointing inside? Because the result nature is only decided by ALU, because ALU is the one who is solving this. Okay, if anyone else is coming and changing the nature, then what is the benefit of doing execution at ALU? Let anyone else do the execution. So whoever is doing the execution, they should have the authentication to change the nature. Yes or no? I hope you're getting my point. I hope you're getting my point, guys. Okay, so that is the reason why the flags are having the arrow in this way. Okay, so maybe ALU might be requiring some nature, and for some next job, maybe ALU might be requiring the job some information. So it can even take from the flag. Okay, so in the next class, what I will do, I'll explain you why the arrow is in two way here. In the next class, we'll understand this part. Okay, we'll see some more examples also, and we'll try to understand. So now I assume you have understood almost all the internal part except this part and this part, and all these pins information what they are actually doing. Except this part, you have understood each and everything. I hope I am correct. Just confirm me. Yeah, okay, fine.